What's up, Vipers? Thanks for joining me for a new episode on This Week with Cheek. Today we'll be at the board learning how to approximate the square root of a non-perfect square to the nearest tenth. So let's go ahead and jump in. First, this is a list. This has the first 30 perfect squares. Now, all I'm asking you to do is memorize the first 25. So we'll stop here. But over the next couple of weeks, we'll be training our brains to memorize the first 25 perfect squares. See, we know what the square root of a perfect square is going to be because we can identify what whole number multiplied by itself gave us 36 or gave us 100. However, when we have a non-perfect square, it's a little more difficult to be accurate. In fact, we've got to approximate to either the tenths or the hundredths place. So let me give you a few examples. Let's take the square root of 19. 19 is not a perfect square. And so there are a few steps that we're going to take. And we're just going to be estimating, this first example, we're going to estimate between two consecutive whole numbers. Two consecutive whole numbers. First step, identify the perfect square that comes before and the one that comes after. So I'm going to flip back to our list. And if we look for 19 on here, you'll see we do not see it. But we can identify here that it comes between 16 and it comes between 25. Those are the two perfect squares before and after. Wrong way. So I'm going to place 16 here, and I'm going to place 25 here. Step 2, I'm going to take the square root of these two perfect squares. And that is my answer. Now, I can explore and find out, guess, how close I think the square root of 19. Is it closer to 4 or is it closer to 5? So if we look here, the difference between 19 and 16 is 3. The difference here is 6. So I would say this is going to be closer to 4 than it is 5. So this is an example of estimating between two consecutive whole numbers. Let's take a look at approximating this to the nearest tenth and getting a little bit closer. So here I've got a number line. And what I want to do now is see if I can locate. We already looked to see how close it was to 16 or 25. The square root of 16 or the square root of 25. And so now I really want to start to get an idea. Is it halfway? Is it less than half? Or is it more than half? Like we said on the previous example, the square root of 19, I think it's a little closer to the square root of 16. Okay? And if we look, I've got it on this number line here. I've got some numbers here. This is what you're looking at. Okay? This is what you're looking at. So the square root of 19 is going to be about 4.4. Square root of 19 is going to be about 4.4. Now, let's say we weren't quite sure it was 4.4 and we needed to check our answer. Okay? What we're going to do is we're going to take anything that's close. So let's say 4.3, 4.4, and 4.5. And what we do is we're going to square each one of these numbers and see how close we get to 19. So we're going to square 4.3, we're going to square 4.4, and we're going to square 4.5. Okay? Grab my calculator so I don't take up all this time with multiplication. So 4.3 squared is going to be 18.49. 4.4 squared, 19.36. 4.5 squared is 20.25. So what we want to do is we're going to look and see which one is closest to 19. Doesn't matter if it goes over. We're just looking for the one that's the closest. And you can see 4.4 is the closest approximation to the square root of 19. So In class tomorrow, this is what we're going to be introducing. This is what I'll be teaching. Hope this preview helps you out. See you tomorrow.